Hello everyone, I am Meghna from Tech World in English. Today I am going to tell you about page replacement algorithms. Page replacement algorithm is an algorithm through which the pages from the secondary memory are moved into the primary memory. There are four page replacement algorithms. They are FIFO, first in first out, LRU, which stands for least recently used, LFU, which stands for least frequently used, and optimal page replacement algorithm. In this video, I am going to tell you about optimal page replacement algorithm. Optimal page replacement algorithm is used when a page needs to be swapped in. The OS swaps out the page whose next use will occur farther in the future. That is, whose page is not used for the longest period of future is replaced. Consider the following example. The things which are written in black are the reference strings. Now, in this, I am using only 3 frames which are present in the main memory. Now, let us consider the 7 is the one which has to be entered in the main memory, and I placed 7 here. Since this is a new page to the main memory, we have to put a page fault here. Later, 0 has to be entered into the main memory. Since there is no 0 here, we have to use a page fault here. And 7 has to be written as it is. Now, 1 has to enter into the main memory. Since there is no 1 in the before pages, we have to use a page fault here, and every time we have to repeat the before pages values also. Now, 2 has to enter into the main memory, but there are only 3 frames here. Now, in order to put 2 into the one of the frames, we have to replace any one of the pages with 2. Since this is optimal page replacement, we have to check the before 3 reference strings. Now, the before 3 reference strings are 7, 0 and 1. Since 0 is occurred in the next position, we must not replace 2 with 0. And we have to check for 7 and 1. And 1 is the reference string which has occurred at last. But 7 is a reference string which did not occur at all. So we have to replace 2 with 7. And we have to write remaining things as it is. And we have to put a page fault here because 2 is new to the main memory. Now 0 is the reference string that must enter into the main memory. Since 0 is already present in the before pages, there is no need to replace. And we have to write the same thing as it is. And page fault is not used here because 0 is already present in the before frames. Now 3 is the reference string that has to be entered into the main memory. Now check the before 3 reference strings because we have used only 3 frames here. Now the before reference strings are 1, 2 and 0, and 0 is followed by 3, so there is no need to replace 0, and we have to check for 2, that is here, and later we have to check for 1. So since 1 is much far, so we have to replace 3 with 1. And we have to write remaining things as it is, and we have to put a page fault here because 3 is new to the main memory. And again 0 is the reference string. Since 0 is already present in before frames, there is no need to replace, and we have to write the things as it is, and no page fault is placed here. Now consider the reference string 4. We have to consider the before reference string 0, 3, 0, and we have to check for the reference strings here. 3 is the reference string which is occurred first, later 0 and later 3. So we have to replace 0, any one of the zeros, with 4. Here 2, 4 and 3. We have to put a page fault here because 4 is new to the main memory. Then again the reference string is 2. Since 2 is already present in the before frames, we just have to write the things as it is, and no page fault is used here. Then 3 is the new reference string. Since 3 is already present in the before frames, there is no need to use a paste fault and we have to write the things as it is. Now consider the reference string 0. In order to place 0 in one of these frames, we have to check the before 3 reference strings, that is 4, 2 and 3. And 3 is repeated here and 2 is also the next reference string, but 4 is not present. So we have to replace 4 with 0, that is here, and we have to write the remaining things as it is, and a paste fault is put here because 0 is new to the main memory, and at a time only one page is replaced. Now consider the reference string 3. Since 3 is already present in the main memory, there is no need to replace and no paste fault is written. Now consider the reference string 2. Here 2 is already present in one of the frames, so we just have to write the things as it is and no paste fault is written. Now consider the reference string 1. Here, in order to place 1 in one of these frames, we have to check the before 3 reference strings, that is 0, 3 and 2. Since 2 is repeated here, we can use any of these frames, that is either 0 or 3. I am placing the 1 here and I am writing the things as it is, and I am putting a paste fault here because 1 is new to the main memory. And consider the next reference string 2. 2 is already present in before frames, so we have to write the things as it is and no paste fault is written here. Now, after completion of this, we have to consider the page faults count. 4, 8. Page faults count is 8.